Hi guys, welcome to my channel. Today, we're simplifying matrix operations for you. We'll break down the basics of matrices and walk you through key operations like addition, multiplication, and finding the determinant. By the end of this video, you'll have a solid understanding of these fundamental matrix concepts. Let's dive in. First things first, what is a matrix? A matrix is a rectangular array of numbers arranged in rows and columns. The size of a matrix is given by the number of rows, denoted as m, and the number of columns, denoted as n. For example, a matrix with 3 rows and 2 columns is called a 3x2 matrix. Always remember, the number of rows is written first, followed by the number of columns. Now, let's talk about the types of matrices. A matrix with 1 column is called a column vector, and a matrix with 1 row is called a row vector. If the matrix has the same number of rows and columns, we call it a square matrix. And remember, single numbers in matrix operations are known as scalars. Two matrices are considered equal when they have the same size and corresponding elements are identical. Another important type is the zero matrix, also called the null matrix, where all elements are zero. Square matrices have some special types, like diagonal matrices, where all elements except those on the main diagonal are zero. If every element on the main diagonal is 1, we call it the identity matrix. Let's get into operations. First, matrix addition. You can add to matrices if they have the same dimensions, by adding corresponding elements. Matrix subtraction works similarly, just subtract corresponding elements. For multiplication, things get a little more interesting. You can multiply to matrices only if the number of columns in the first matrix matches the number of rows in the second. Multiply corresponding elements and sum them up. Now, on to determinants. The determinant of a square matrix is a number that provides information about the matrix, such as whether it's invertible. For a 2x2 matrix, the determinant is calculated as ADBC. If the determinant is 0, the matrix is singular, meaning it doesn't have an inverse. For larger matrices, determinants are calculated using cofactor expansion, which breaks the matrix into smaller pieces. Next, let's talk about transposing a matrix. To transpose a matrix, you swap its rows and columns. For example, if the first row of matrix is 1, 2, 3, after transposition, this row will become the first column. The transpose is helpful in many applications, especially when working with matrix equations. Now that you've learned the basics, it's time to practice. I've got some problems for you to try. Add to matrices, subtract to matrices, multiply to matrices, calculate the determinant of a square matrix. Share your answers in the comments, and I'll check them out. That's it for today's video. I hope you now feel more confident working with matrices. Don't forget to like, share, and subscribe for more simplified math tutorials. See you next time.